right. Good morning to everyone. Good morning, good morning, good morning, good morning. All right, so I hope we are well and I hope we are good. So this is a grade 9 session, and for those who are joining in for the first time, welcome. Hopefully, the session will be very beneficial to you guys. I hope you all enjoyed your Christmas and you guys enjoyed your boxing. Was it Boxing Day? It was yesterday. Um, yeah, and I want to say as well that I appreciate your guys' sacrifice being here this morning. I know some of you are still caught up in the festivities of the past 2 days, but to make the sacrifice to be here is amazing. So I'm glad you could join in. And then just a reminder that one, we obviously cover work here that is based on what we'll be doing at the beginning of next year, term 1. And so far there's a lot that we've covered. And if people are joining in for the first time, remember that you can always go to the YouTube page, and the YouTube channel has all the sessions that we've done so far. And for grade 9, we had been doing combined sessions with grade 10 because the beginning of the work that you guys do in grade 9 is very similar to the grade 10 work. So if you go to the YouTube channel is called Maths is a Game. You can always go to my bio and click on the YouTube icon that's there. It will send you directly to my YouTube page. And then when you are there, you can subscribe, and then there are videos of the live sessions that I've done for grade 9 and 10. Some of the videos you'll see on the thumbnail that it's written grade 9 and 10, because I've covered sessions that have both covered grade 9 and grade 10 work. And then only now, I think in the last session that we did before the 25th, did we start branching off alone as grade 9s, and continuing on, we'll branch off until the end, because the grade 9 work is different and set apart from the grade 10 work now as we move forward. So now I'm going to start with the grade 9 session. At 8:30 I will have a grade 10 session. At 10 a.m. we'll have a grade 8 session, and then at 1 p.m. we will have a grade 11 session. Then later on in the afternoon at 4 p.m. I'll be hosting the first grade 12 session for the mathematics term 1 work. So please make sure that you do share I think at least the poster video that is on my page, the TikTok page, that basically has the schedule for today, with those that you know that may need to be part of something like this, so that they can join in the progressive work that we are doing here. Then the second last announcement I want to give is that after every live session there is game challenges that I send, what you would know as homework at school. Please guys, do that homework or that game challenge. Why? Because me teaching you will not have any effect unless you actually then sit down, look at the work that I have sent for you to do as a game challenge, and actually do it and see if you can do the work on your own. It is only after then that you can determine as to whether you've learned something or you haven't. Then if you are not part of the WhatsApp group already, that's the second announcement. If you are in grade 9 and you're not part of the WhatsApp group, I would also encourage you to be part of that, because there I always send announcements that are related to the group. Yeah, you are more than welcome to send me a TikTok inbox message if you want to be part of that, and then we can always send you the link of that WhatsApp group so that you can join it. And then, yeah, any other material or any other resources for mathematics that you may need will be forwarded to that WhatsApp group. And any other relevant communication that is pertaining to the live sessions will be communicated to that group. But yeah, for now, I think let us begin. So like I said, this is grade 9 mathematics, and we'll be looking at how to, what the lowest common multiple is and what the highest common factor is, and how to determine that using methods in grade 9. You guys have done it in grade 8, but we'll be looking at how do we actually go about finding the LCM, the HCF in grade 9 as well. So I hope you guys are ready for that. But I think before I jump into that, I want to look at some of the work that I had asked you guys to cover and to do for homework. So I'll just upload just very quickly. Hello, I'm just a girl. Hello, morning. All right, just very quickly. I want us to look at the following questions very quickly just before we jump into what we're going to cover today, just so that we can see if we are all on the same page. There's a question there that says, write down the factors of 24. I'm not so sure if you guys can see that. I hope you can. Just by way of commenting in the comment section, please answer the question. What are the factors of 24? If you can just list them, please use the comment section and write down what the factors of 24 are. What are the factors of 24? In other words, when we say factors, these are numbers that fit into 24 without leaving a remainder. In other words, numbers that can that go into 24 without leaving a remainder. What are those numbers? Can we list what the factors of 24 are? List all of them, not just some of them, but all the numbers that go into 24. You guys can just list them, all of them. What are those numbers? So you can actually just, if you have a pen and a paper in front of you, you can write down the number 24 and then list the numbers or the factors of 24. Okay, let's say you've just listed the factors of 45. I want the factors of 24. Yes, let's say the factors of 24. Otherwise, you've answered the later on question, which is great. But I'll go back to it when we come there. But for now, I want us to list the factors of 24. What are the factors of 24? the numbers that go into 24 without leaving a remainder. Yeah. Okay, so I'm looking at you guys' answer. Quincy Litabe says 2, 4, 6. Lesejo says 1, 2, 3, 4, 6, 8, 12, 24. Little Victor says 1, 2, 4, 6. Underscore Sia. Alright. Okay. So remember, what are factors? Factors of a number are those numbers that divide exactly into a whole number without leaving a remainder. So remember, I said I want all the factors. I want you to list all the factors. So if we look at Quincy's answer, Quincy said 2, 4, 6. And yes, Quincy is right in that 2 does go into 24, 4 does go into 24, and 6 does go into 24. But then my question is, are those all of the numbers that go into 24? So there seems to be some numbers that are missing Quincy. Let's look at little Victor's answer, 1, 2, 4, 6. So little Victor added 1 to the numbers that Quincy had actually written down. But are they all there, little Victor? It seems like they're not all there, okay? Then if we go to my good friends, let's say underscore Sia and Tylas, you can see that they have listed 1. So 1 does go into 24. How many times? 24 times. Now you can see that there's the 1 at the beginning and the 24 at the end. Then the next number after 1 is 2. 2 goes into 24 how many times? 12. So you can see 12 is also there. Then the next number after 2 is 3. Yes, 3 does go into 24 how many times? 8 times, and 8 is there as well. And then last but not least, 4 does go into 24. How many times? 6 times. And yes, 6 is also there. Does 5 go into 24? No, it doesn't. So that means that those are all the numbers. Okay. So Ulesejo underscore Sia and Uxoxo were able to identify all of the numbers that go into 24. Okay. And then Quincy, I see you said 1 and 12. You've added 1 and 12, but we are still missing a few other numbers, 3 and 8 and 24. So what I do then suggest is that when you look for the factors of a particular number, please people, when they ask for them, we need to be able to write all of them, all right? If you miss one, then you do not get the marks that are due to you, okay? So I hope we can all understand why it is that 1, 2, 3, 4, 6, 8, 12, and 24 are the factors of 24. And we need to list all of them. So good job to Xaxla, to underscore Sia, and to Ulesejo for actually identifying all the factors. Okay, let's move on to the next question. What are the even factors of 24? Okay, so now we're not looking only for the factors of 24, but we want the even ones, the ones that are even numbers. So what are the even numbers? What are the even factors of 24? So we need to first understand what does the question want. The question wants the factors of 24 that are even numbers. So can you list those factors of 24 that are even numbers? Just only those that are even numbers. That's what we call even factors of 24. What are the even factors of 24? Alright, Tata has listed some. What does everybody else say? Okay, little Victor also has listed some. Okay, Lesejo as well has listed some. Alright. Okay, now look at what you guys have listed. Utaka has said 2, 4, 6, 8, 12. And if you go back to that list of factors that we had listed, all of them, alright, Atla has listed some of the even factors, not all of them. Little Victor has said 2, 4, 6, 8. And yes, those are even numbers, but those are not all the even numbers that are listed as factors. And then Lesego has said 2, 4, 6, 8, 12, 24. Now Lesego has listed all the even numbers that are factors of 24. So who would I mark 100% correct? It would be Lesego. So let's make it a point, guys, that when we list the factors, the even factors, we identify all the even numbers that are factors of 24, not just some of them. So Ukaka listed some of them and did not include 24, which is where you fell short. Little Victor, you listed some of the factors, you didn't include 12 and 24. And then Lesego was able to list all of the even factors of 24. So good job, Lesego. And please guys, let's get on board and make sure that we list all of the numbers that are factors of, all of the even factors of 24, not just some of them, okay? So that's very important. And I want to emphasize that point because you don't get all of the marks if you miss one or two of the numbers. Are you with me? All right, let's move on. Number 3, what are the prime factors of 24? Prime factors. Now we go back to our list of factors and we want to identify those factors that are prime numbers. Remember, what are prime numbers? Prime numbers are numbers that have two factors, one and itself. All right, so it's very important that we remember what prime numbers are. So now what we want to do is we want to list the prime factors of 24. So what are the prime factors of 24? All right, so let's look at your answers. Ruru said the prime factors of 24 is 3. Okay, then Lesego says 3 as well. Then little Victor says 3 and then says 24. Princess says 1, 2, 3. Lesego says 1, 2, 3, updating her previous answer. And then Ukaka says 2 and 3. So let's look at you guys' answers. Ruru said 3, and yes, 3 is a prime factor, all right? But is it the only prime factor that is in that list? Okay, it seems like there's a prime factor that is missing. Little Victor, 3 and 24. 24 is not a prime number. Why? Because 24 does not have only two factors. 24 has more than two factors. So 24 is what we refer to as a composite factor. So it's not a prime factor. So 24 should never have been listed. Princess, you said 1, 2, 3. The only number that shouldn't be there is the number 1. Because remember, 1 is not a prime number. Otherwise, the rest, 2 and 3, are definitely prime factors. Lesego as well, you updated your answer. 1 shouldn't be there. And then lastly, Ukaka is spot on. The prime factors of 24 are actually 2 and 3. So Kaka is definitely spot on. The prime factors of 24, guys, you go back to your list of factors that you had listed, and from there you identify the ones that are prime numbers. And the only prime numbers in that list of factors that you had is 2 and 3. All the rest, okay, are not prime numbers, and that's very important to identify. All right, guys, I hope you guys are seeing, okay, this thing. That's how we go about doing this. Right, let's look at these, the next 3. What are the factors of 45? I want us to do the next one. What are the factors of 45? Remember, what are factors? Factors are numbers that divide exactly into another number without leaving a remainder. And what we want here is we want us to list all of the factors without missing any single number. What are the factors of 45? Okay, let's say Jose says 1, 3, 5, 9, 15, 45. Princess says 1, 3, 5, 9, 15, 45. Sbongile also says 1, 3, 5, 9, 15, 45. Okay, and we can absolutely say without any hesitation that Lesejo, Princess, and Sbongile are all spot on. Let's look at each number. 1 does go into 45. How many times? The last number shows us how many times does 1 go into 45, and that is it goes into 45 times. So that's why we have 1 at the beginning and 45 at the end. That's how I write the factors. I list the numbers. If I list 1, then I'm going to check how many times does 1 go into 45. 45 times. Then I will write the end number at the end. Then I look at the next number after 1. Does 2 go into 45? No, it doesn't. 2 goes into 45 but leaves a remainder, so it's not a factor. So the next number after 2 is 3. How many times does 3 go into 45? It goes into 45 15 times. That's why you have 15 before 45, which is the many times that 3 goes into 45. Then the next number after 3 is 4. 4? No, it doesn't go into 45. It leaves a remainder. What about 5? 5 does go into 45. How many times? 9 times. That's why 9 follows before 15. Are you with me? Then does 6 go into 45? No. 7? No. 8? No. Then 9. 9 is already there. So now we have all the factors of 45. People, please make it a point that when you write factors, you write all of the factors. Don't miss out one number, okay? Okay, let's move on to the next question. The factors of 45 that are composite numbers. What is a composite number? A composite number, if you remember our definition, is a number that has more than 2 factors. A composite number is a number that has more than 2 factors. So from our list, we want to identify the numbers that have more than 2 factors. So from our list of factors, what are the composite numbers that are factors of 45? The factors of 45 that are composite numbers. Which ones are they? From our list. 1, 3, 5, 9, 15, 45. Which numbers there are actually composite numbers? So the factors of 45 that are composite numbers. from our list. Remember what I said, from the list that you had written of factors of 45. Which numbers there are actually composite? Okay. So I'm just going to give you 30 seconds more to answer that question, and then I'll go over the actual answers. Okay, 30 seconds is up. Right, let's look at the answer. So let's say Jose has 15 and 45. Atla says 4, 15 and 45, and then she changed the answer to 15 and 45. Underscore Sia says 15 and 45. Sbongile says 1, 5, 25. Little Victor says 9 and 15, and then Sbongile changed again and said 1, 5 and 45. Guys, let's look at the actual composite factors. Now, let's take note. Let's say Jose says 15 and 45. 15 and 45, yes, are composite numbers. But are those the only composite numbers that we have listed in that list of factors that we had written down of 45? Definitely not. So there's a number missing there. Atla says 15 and 45. Once again, is that the only composite factors we have there? Definitely not. Underscore Sia says the same, so definitely not. Sbongile says 1, 5, 25. 25 was not even in the list. So Sbongile, to write 25, I see you fixed it then. You said 1, 5, 45. But the only thing that's off there is that 5 is not a composite number. It's a prime number. So that's not correct. As for 1, 1 is not even a composite number. So it's incorrect to write 1. Little Victor, 9 and 15. 9 is correctly a composite number and 15 is, but you are missing one number there from your list. All right. Underscore Sia as well. 1 is not a composite number. 3 is not a composite number. 5 is not a composite number. So you've listed 1, 3, 5, which are not composite numbers. 9 and 45 are composite numbers. So even from you would be incorrect. Okay, and then I see Ulesejo added the number 9 to her list of numbers. Okay, so it's very important, people, that we identify the right composite factors. All right, so the composite numbers that would be 100% correct would be 9, 15, and 45. All of those are composite factors. Okay, yeah. Guys, I just want to stress that these are grade 8 questions, right? You guys are in grade 9. So these questions, you should at this stage be able to answer them. But I do want to encourage you that you do make sure that you don't just answer these questions carelessly. You need to take the time to think about the things that you write and ensure that when you've listed numbers according to the question that has been given, you list all of the numbers that are relevant to that particular question. But in order to do that, you need to understand your definitions. You need to know what a prime number is. If you don't, you're going to write the wrong answers. All right? And that's going to fail you in that regard, because it's not that the math is difficult. It's just that you don't care enough. You are a bit careless in your interpretation of what the definitions mean. All right? So please, let's not take this for granted. Okay? I hope you guys are with me. So the answer should be 9, 15, and 45. Right? I'm going to ask a question that's not listed here, and I want you guys to answer it. If they had asked what are the prime factors of 45, what are the prime factors of 45? I want you guys to write down the answer. What are the prime factors of 45? So that means we want the factors, that are actually prime numbers from the list of the factors of 45. What are the factors that are prime factors? Remember, guys, a prime number is a number that only has two factors. All right? Please, prime number is a number that only has two factors. Okay? So, Gaga says 135. Okay? Once again, 1 is not a prime number. Let us put that in our heads. The number 1 is not a prime number, guys. Prime numbers start at 2. All right? So, yeah, 1 is not a prime number. So, for you to say 135 is incorrect, because the only number that's off there is now the number 1. Let's say Echo says 3 and 5, which is spot on. Little Victor says 3 and 5, which is 100% spot on. And then Princess says 3 and 5. So take note, the number 1 is not a prime number. Okay. So hopefully we are starting to pick up the momentum and we're starting to see, oh, okay, all right, makes sense. I wanted to ask this question. What if I had asked, what are the even factors of 45? Please list those. What are the even factors of 45? The even factors of 45. The even factors of 45. What would you say? The even factors of 45. In other words, the factors of 45 that are even numbers. Okay, little Victor says there's no even factors, sir. That's his answer. What does everybody else say? Princess says none. Are you guys sure? Lesejo says yes, there's no even factors. Underscore here says 1 and 45. Can we speak to that? Underscore here says the even factors of 45 are 1 and 45. Underscore here, do you know what an even number is? An even number is a number that is divisible by 2. Right? An even number is a number that is divisible by 2. In other words, if you take that number that you've listed and you divide it by 2, all right, it should leave a whole number. Okay, so underscore here, to say 1 is an even number, yo. And to say 45 is an even number, yo. Okay. So you guys, everybody else that has written down, little Victor was spot on. There are no even factors, guys. Princess, you are correct. Let's say 100%. Kakla, you are 100% correct. Okay. So let's get with the game, guys. Like I said, maths is a game. If we are not going to really take into consideration what the meaning of words is here, then guys, we're gonna really mess things up here, okay? And there's no one to blame but yourself if you don't understand what the meaning of the words are. So in the first few sessions that I did with grade 9, I explained what the terms mean. So if you missed out on those things, please do go back to the first few videos that I did on my YouTube channel and watch them so that you can develop your conceptual understanding of the terms. Terminology in maths is important. Understanding of words, what they mean, is important. Interpreting those words correctly so that you can attach meaning and answer the questions correctly is important. Please, guys, all right? So take that for granted. Now let's move on to this question. What are the factors of 45 that are multiples of 5? The factors of 45 that are multiples of 5. Okay, remember, what is a multiple? Right. When we concluded the session last week, we concluded by defining what factors and multiples are. A multiple of a number is obtained if the number is multiplied by natural numbers. So if you want to look at that list and look at the numbers that are, we want to look at the factors of 45, identify the numbers that are multiples of 5, the numbers that are multiples of 5. So I like the answers that I'm seeing here, with the exception of one person's response. Alright, so Princess says 5, 15, 45. Lesejo says 5, 15, 45. Little Victor says 5 and 45. So let me congratulate Princess and Lesejo, 100% spot on. Little Victor, you are correct, but you are missing a number. So once again, this is a situation where you've basically omitted to write 15, and that will cost you because you will not get awarded the marks simply because you missed out on one factor, and that is 15. So 5 is definitely a multiple, all right, which is a factor of 45. 15, definitely, and then 45, all right. It was amazing, Klochi, very much amazing. I hope yours was good too. All right. Okay, guys. I hope you guys are seeing this. Let's look at the very last bottom question there. The last question says the factors of 72. What are the factors of 72? How was yours, Edloche? How was your Christmas? The factors of 72. What are the factors of 72? So I'll give you a minute to answer that one, the factors of 72. I think a minute or two will be good, a minute or two. Right, so it's 7:43 and 7:45. I'm going to close people responding. The factors of 72. So I'm hoping you guys are taking the time to not just look at the answers that people are writing here. Like, I hope you are taking the time to actually write down for yourself, because remember, at the end, when you are in a test situation, you need to be able to identify the factors on your own, okay? So Sbongile has answered for herself. I hope everybody else can answer for themselves. Don't take Oh, okay. Oh, the live settings. I wonder how is it that Smongile was able to answer. All right. Okay. No, then that's fine. That's fine. I've noted what you said. Lesejo, little Victor. Okay, underscore Sia says I also can't post my comment due to live settings. But underscore Sia, you've posted your comment above. I see you have 1, 2, 3, 4, 6, 8, and 9. You've listed those comments. You've listed those values as your factors. Right. So guys, yes, just to look at the answers, Mongile is spot on there. 1 does go into 72. How many times? 72 times. So 1 and 72, definitely there. Followed by 2. 2 goes into 72. How many times? 36 times. So 36 is there. Then followed by 3 after 2. 3 goes into 72. How many times? 24 times. 100%. 4. 4 does go into 72. How many times? 18 times. 100%. Then 6. 6 does go into 72. How many times? 12 times. 5 doesn't go in, so that's why we skip 5. 6 though follows and it goes into 72. How many times? 12 times. 7 doesn't go into 72, so we follow it by 8. 8 does go into 72. How many times? 9 times. So Smongile has written everything. Okay, no problem, babes. Forever, no problem. Okay, no problem. Okay, but hopefully you guys, we all can see what the factors are. We kind of all now understand. Okay, so yeah, those are the factors. And remember, like I said, guys, we need to be able to list all of the factors. Okay, we need to list all the factors, not some of them, but all of them. Okay, yeah. So hopefully we can understand why it is that we've written those as the factors. So the factors of 72 are 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. Now, next question. What are the prime factors of 72? So from those factors, which numbers are prime? Prime numbers. What are the prime factors of 72? I repeat, what are the prime factors of 72? Okay, Taka says 2 and 3. Spongile as well follows it up with 2 and 3. Let's say 2. Okay, guys, those are the prime factors. Definitely. Babeska forever. Thank you so much. Alright, guys, those are the prime factors of 72. I don't want to go on any further. The next question is the factors of 32 that are also factors of 36. The factors of 32 that are also factors of 36. Which ones are those? The factors of 72 that are also factors of 36. factors of 72 that are also factors of 36. The factors of 72 that are also factors of 36. So hopefully here you guys can see that you already had the factors of 72 written down. So you need to then write down the factors of 36 as well, and then check which ones appear for both, because you want the factors of 72 that are also the factors of 36, and you need to list those that are factors for both, you know. The factors of 72 that are also factors of 36. Yeah, I'm going to have to fix these live settings, that's for sure. Seems as these live settings are limiting. Alright, no, that's fine. I think we'll hold it right there. Hopefully you guys got the following. 1. Alright, let's see. It seems like Kaka has been able to cross through the live settings. Let's see. Kaka has said 1, 2, 3, 4, 6, 12, and 36. Kaka is missing some numbers there. Okay. Hopefully you guys can see the numbers that Kaka is missing. Alright. Otherwise these numbers are correct, but there's a few that are missing that are supposed to be included there. Can we identify the numbers that are missing from Kaka's list? 1, 2, 3, 4, 6, 12, 36. What number is missing? What numbers are missing there? Just the numbers that are missing, so that we can add them on. Okay, underscore here says 918, and then there's one more. Oh yeah, okay, no, that's true. 918, 100%. You guys are spot on. Underscore here and Lesejo, you have basically identified the next few numbers that are supposed to be there. Thank you very much. Good job. So it's supposed to be 1, 2, 3, 4, 6, 9, 12, 18, and 36. Spot on. Okay, then the last question I'm going to ask, what are the factors of 72 that are multiples of 4? Factors of 72, but those factors of 72 are also multiples of 4. Factors of 72 that are multiples of 4. factors of 72 that are multiples of 4. So firstly, you need to try and understand what the question means. And then after understanding what the question means, then you will write your answer. Don't just write the answer. So these need to be factors of 72. But those factors of 72 also need to be multiples of 4. Alright. So if you look at your list of factors of 72, which ones can you identify as factors? Which one can you identify as multiples of 4? Lesejo added in 72. But are those all of them? Little Victor, I understand, that's fine. Alright, so the last number that's missing the lesejo is 36. I'm going to try and fix the settings, okay? Because it seems like there's a problem there. 18 is not underscore C. 18 is not a multiple of 4. It's not at all. Alright, so that's incorrect. So lesejo, you are correct by saying 4, 8, 12, 24, and 72. The only missing number there in your list is 36. Okay, 36 is also a multiple of 4, which is also a factor of 72. Okay, guys, I'm gonna hold it right there, but hopefully you guys can see why it's so important to know, why it's so important to write things to completing the numbers, making sure you write all of the numbers, and making sure that you understand the definitions of the various terms, like what prime number means, what composite number means, what even number means, what odd number means. If you understand the terms, then you should be able to interpret and write the correct answers. Right? Okay. It's more important to understand the terms here and then to be able to identify the correct numbers. Okay. All right. So let's move on, guys, and look at what we basically wanted to look at today, which is identifying or writing down the lowest common multiple, King 812, as a picture, that galaxy of your LCM and HCF. So let's say we appreciate the thought and the sentiment here. Lowest common multiple and highest common factor. So let us remove the picture. It served its purpose. And let's look at something that you should know from grade 8. The question says, determine the LCM of 36, 60, and 90. And using Prime Factorisation. Okay. Determine the LCM of 36, 60, and 90. Now firstly, what does LCM stand for? It stands for lowest common multiple. Lowest common multiple. So in grade 8, you guys should have learned how to determine the LCM of numbers using what we call prime factorization. So typically what you would do is you would take 36. You would either use the tree diagram or the ladder method. You'd write 36, you'd write 60, you write 90, all right, all of them. Then you identify the prime number, the smallest prime number. Remember, that goes into 36. Okay, so what is the smallest prime number that goes into 36, guys? Smallest prime number that goes into 36. 2. How many times does it go into 36? How many times does 2? 18 times. Okay, next prime number. What is the smallest prime that goes into 18? How many times does it go into 18? It goes in 9 times. What is the smallest prime number that goes into 9? Okay, 3. How many times does it go into 9? Okay, 3 times. You guys get the actually. And then what is the smallest prime number that goes into 3? Okay, it's 3. And then how many times does it go into 3? Once. And this is where you stop. So that means 36 is actually written as a product of prime factors. It can be written as 2 times 2, 2 times 2 times the 3 times the 3, right? In other words, 36 can be written as 2 squared times 3 squared. Do you guys still remember that? You still remember that? Okay. Babes forever, just let's take it one step at a time. I understand that you may know the answer already, but well, actually, let's just hold our horses there before we jump to conclusion. Okay, you still remember this. Okay, do the same thing with 60. Do you still remember? We do the same thing with 60. Smallest prime number that goes into 60. Grade 9, but revision of grade 8. 2, definitely. How many times does it go? I'm going to be a bit fast now, okay? I think you guys get the drill. So 2 goes into 60, 30 times. Smallest prime number that goes into 30, 2. How many times does it go into 30? 15 times. Smallest prime number that goes into 15, 3. How many times does it go into 15? 5 times. Smallest prime number that goes into 5, 5. How many times does it go into 5? 1 time. Then 60 can be written as 2 times 2 times 3 times 5, which is actually equal to 2. How many 2's do we have? 2 2's. How many 3's? 1 and 5, 1. Okay. Then we move on to 90. Smallest prime number that goes into 90. That's 2. How many times? 45. Smallest prime number that goes into 45. 3. How many times does it go? 15 times. Smallest prime number that goes into 15. 3. How many times does it go into 15? 5 times. And the smallest prime number that goes into 5. 5. How many times does it go into 5? Once. Okay. So then 90 can be written as 2 times 3 times 3 times 5. So then our answer would be 90 is equal to 2 times how many 3's? There's 3. How many 3's? 2 3's. How many 5's? 1. Alright. So I hope you guys still understand this thing. This was how we went about prime factorizing numbers All right, and it worked out nicely. Then we want to now write down the lowest common multiple from these prime factorized bases. So this is how we would go about it. 36 is equal to 2 squared times 3 squared. 60 is equal to 2 squared times 3 times 5. And then 90 is equal to 2 times 3 squared times 5. Alright. Then this is something we would then look for here. I just want to write this down. This is what we look for. Identify the base. In other words, when we mean base, right? 2 here is a base. 3 here is a base. 5 is a base. Alright? That's what we mean. So we are going to identify the base that we are going to identify, in actual fact, the common base. This is important. Identify the common base that has the highest. Right? Identify the common base that has the highest exponent. Identify. We are going to identify the common base that has the highest exponent. Do you see that? Identify the common base that has the highest exponents. And leftovers. Alright, and I'm going to explain what do I mean by leftovers. If the leftovers are common, we go for the base that has the highest exponent for the leftovers. I'm going to explain what I mean by leftovers. Okay, hopefully that makes sense. I saw that smart study. I think we can celebrate that the page has officially reached 10k followers. I actually noticed that last night before I went to bed. So we are going to identify the common base that has the highest exponent and the leftovers. But I'm going to explain what do we mean by leftovers. So let's look at this. 36, 60 and 90 have, look at the base. Base 2, base 2, base 2. That is common, right? Base 2 is common for all three numbers. So we are going to identify the common base that has the highest exponent. If you look at this base, it has the exponent, we would write 1. This one has the exponent 2, this one has the exponent 2. So for our LCM, we are going to say LCM is equal to identify the base that has the highest exponent out of the base 2. That means we are going to write 2 to the power 2. Identify the common base that has the highest exponent and the leftovers. Write the product of these. That's our LCM. Okay, write the product. Product means the multiplication of these after we've identified them. So for base 2, we go for 2 to the power 2 because 2 to the power 2 is the base that has the highest exponent out of our common base 2. Make sense? Let's go to 3. 2 is done. We are done with 2. We move on to the next common base, which is 3. So we have 3 squared, 3. We know this would be 3 to the power 1, and then we also have 3 squared. So which base has the highest exponent? It's obviously 3 to the power 2. So we write that as a product to 2 to the power 2. We write 3 to the power 2 as a product. Then we can see 5 is not here for 36. But for base 5, for the number 60, we have 5 here, we have 5 there. These are what we call our leftovers. But for our leftovers, which one is the common base for the two numbers that has the highest exponent? It's obviously going to be just 5. So we write down that common base once. So we write base 5 as a product to 2 squared and 3 squared. Okay, So let me repeat this again. After prime factorizing your 36, your 60, and your 90, you go and identify the common base that has the highest exponent. We're looking for the LCM, which is the lowest common multiple. But when we identify the common base, we go for the base that has the highest exponent, the common base that has the highest exponent. Lowest common multiple, we're looking for the opposite, the highest exponent. For lowest common multiple, we go for the highest exponent, the common base that has the highest exponent. And we look at the leftovers. Then we write the product, meaning the multiplication of these. So like I said, for 36, 60, and 90, 2, base 2 is common. So I'm going to go for 2 to the power 2 because it has the highest exponent. I write it once. Then I look, base 3 is also common for all three numbers. But then I'm going to identify 3 to the power what? 2 because it has the high exponent. I write it once. Then last but not least, 5. 5 is not common for all three numbers. It's just common for the last 2. So I also there go for the base. So we refer to these as our leftovers, all right? These are sort of like our leftovers, but even in there, we look for the base that has the highest exponent, which is 5. Are you with me? These are written as a product. We take our product. 2 squared is 4 times 3 squared is 9 times 5. So this is 36 times 5. You can take your beautiful calculator. If you don't know what the answer is, go and work it out. But of course, you are going to get a beautiful answer of 180. All right? When you multiply these. So the LCM of 36, 60, and 90 is 180. All right? Okay. Because what have we done? We have multiplied together the highest power of each prime factor found in each number. I repeat, we have multiplied, we have identified the common base that has the highest exponent and its leftovers to write the product, which gives us 180. This is the lowest common multiple of 36, 60, and 90. All right. So like I said, this is a grade 8 revision, but it's applicable to grade 9. We are doing grade 9 at the moment. So please guys, we need to know how to find the LCM using this prime factorization method. All right. This is per grade 8. So I just want to introduce Kengoku to the grade 9s that the letter method for you guys is no longer necessary. When you are in grade 9, please, grade 8s, don't listen to this. When you are in grade 9, life is very sweet and soft. What you can do now is, without using the letter method, you can go and use your calculator. And what do I mean by that? The same question that you have been given, you know, when they say determine, this is for grade 9. Please, grade 9s, you are the ones that are listening. I had to obviously do the method for grade 8 so that you guys can remember what you did this year, early this year. But as a grade 9 learner, you can determine the LCM of 36, 60, and 90, okay, using this method, but your calculator can assist you. So instead of using the letter method, to prime factorize, you can use your calculator. How? You're going to ask me. All you simply do, you see the three numbers are 36, 60, and 9. So what you are going to do, you are going to write in your calculator. And I'm just going to write down what you would actually type in your calculator in order to write your numbers as prime factors. You'll say 36 from your scientific calculator, your Casio calculator. Press equal, press shift, and then press fact. Are you with me? Let's go and do that. 36 and press equal, press shift and then press fact with that yellow. What do you see? 2 squared times 3 squared. Your calculator prime factorizes for you. This is for grade 9. Please take note what I've just said. Grade 9s, the ladder method, you no longer have to go ahead and do ladder if you want. You can just use the calculator. You press 36, you press equal, you press shift, you press fact. This is for grade 9s. This is for the grade 9s ears only, not the grade 8s. The grade 8s still need to use ladder method. Grade 9s, this is for your ears only. So then you can just write 36 is equal to, what was your calculator? 2 squared times 3 squared. Are you with me? The next number was what? Was 90? Was 60, sorry. You do the same thing. Go to your calculator. You say 60, right? Press equal, press shift, and then press fact. And there you have it. Look at that. 2 squared times 3 times 5. So all you do, 2 squared times 3 times 5. Alright? And then lastly, 90. You're going to do the same thing. You say 90, right? You press equal, you press shift, then you press shift will basically present you with that S. The minute you say shift, look, if I press shift again, it switches off. But then if I press shift, it's basically that this is activated. This activates all of your yellow functions in your calculator. These yellow things that you have there, it activates those things when you press shift. Are you with me? So you press shift and then you go and press fact. Okay, because we've activated so that we can get the prime factors. Look at that. 2 times 3 squared times 5. 2 times 3 squared times 5. Then Kingoko, from here, what you can then do is from here you identify what? The common base that has the highest exponent. So you're still going to go ahead and say, what is the common base that has the highest exponent for 2? It's obviously 2 squared. Then you move on to base 3. Which one is the common base that has the highest exponent? It's 3 squared. Then you move on to 5. Okay, so 5 is common for these two. So you would identify also for these two the common base that has the highest exponent, which is 5. And then from there, all you simply do is you take your calculator. Okay, you know this is 4 times 9 times 5. And obviously, because you are lazy and you don't want to work out things, you say 4 times 5 times 9. It gives you that 180. And then you can just write that your LCM is 180. Okay. So for those that have been here, are we understanding the shift from grade 8 using the ladder method, which we would do to basically get our prime factors and then identify the common base that has the highest exponent? In grade 9, we can simply utilize our calculator by taking the respective numbers that we've been given, finding the prime factors using our calculator for each number, and then identifying the common base that has the highest exponent for each base, and then being able to write those as a product and get the answer. So this is something that we can utilize using our calculator. And in grade 9, it's fine to do that. Because at least now you have an idea that if you were to use the ladder method, you'd still get those prime factors, but then in grade 9, it makes life so easy for you. Okay, right? Are we together? Because this is where I'm going to actually end for today. Finding the LCM. Okay, remember that LCM is simply identifying from our prime factors, identifying the common base that has the highest exponent. And from our leftovers, we need to also write the base that has the highest exponent. Let's say if the leftovers, let's say for instance, if the leftovers here, let's say there was a 4, let's say here, just for argument's sake, there was a 3 and there was a 7. Those wouldn't have been common, right? It would have been different. You would take that 3 and that 7 and write it as a product. Okay. You'd still take that 3 and that 7 and write it as a product for your LCM. And you would include the 3 and the 7 after the 9, okay? And then you'd write down your answer, your LCM, okay? So this is just a way or a method that we can utilize to make life a bit easy. Without using the ladder method, we can utilize our calculator so that we can get the prime factors, okay? All right, guys, with that said, thank you so much for joining in. We will be continuing with this. Tomorrow is Saturday, all right? I think the same schedule will apply tomorrow, 7 a.m., 9, grade 9, we'll have a session, okay? But yeah, I think that brings us to the end of our session and lesson. I will be sending you some work to do. I'll be sending you some work to do, okay? Yes, grade 10 and 11 will be done, Kaloko. Like I said, those are sessions that are following, but I'm just talking about grade 9. Guys, thank you so much. That was cool. I hope you guys have learned quite a bit. And the new skill, all right, that we need to utilize. So if we just recap a little bit here, remember, guys, that with what we did at the beginning, please make it a point that you understand your definitions. You need to all understand your definitions. If you understand your definitions well, what are composite numbers, what are prime numbers, and then what are odd numbers, what are even numbers, and then the minute they ask you what is the odd factor, what is the even factor of this, what is the prime factor of this, you'll be able to answer the question. Remember, we need to answer the question fully. We need to identify all the numbers. Then lastly, with your LCM, how to determine the LCM. Remember that from grade 8, you may have learned how to use the ladder method and get your primes, your numbers prime factorized, but now you can utilize your calculator for grade 9 and actually find your factors, which can then lead you to getting your LCM. Right, so with that said, like I said, I'll be posting the game challenge, the work that you guys need to do for your practice so that you can see if you've understood and captured the concept. And then also those who are not in the WhatsApp group for grade 9, please do send me a DM message on TikTok here. You can send me a DM message so that I can send you the link for the grade 9 group on WhatsApp so that you can join in. And then also if there's communication that pertains to grade 9 about lessons, about classes, about material maybe that can assist you and help you, or homework that basically, or game challenge problems that you guys need to do, then I can send those to you as well. And any other help or assistance you may need can come via that platform. So thank you so much to the grade 9s. Thank you for joining in. I'll be ending this session, and then the grade 10s, I am meeting with you just now shortly at 8:30. So hope you guys are ready for that. Thank you so much. Let me love and leave you. Till next time. What's up, Matete? Matete is saying, sir, what's happening? What's wrong? So grade 10 will be joining at 8:30 shortly. Okay. Yes, Matete. We'll be posting these on TikTok as usual, okay? On YouTube, sorry. I'll be posting it on YouTube. These videos I can only post on YouTube because they are big, they are too long, too large. So post on YouTube channel, Matters a Game, so you can get them there. All right, so those who missed out, who may have joined in late, yeah, you can always catch up on the YouTube channel. I've posted even the previous videos that I've done on there. So yeah, let me love and live you. Great.